and welcome to this webinar, the second tech crunch in the series that we're going to have once a month. This one is called Optimizing Performance and Scalability in Your Dynamicweb Implementations. The presenter would be me, Nikolaj Petersen. You should hopefully know me, and I'm not as pretty as in this image. This is probably some kind of cheating image. So the agenda for today would be two blocks of information. The first one is called Optimizing Performance on Dynamicweb Implementation. The second one is Scalable Dynamicweb Solutions. Of course, those two subjects are very much related. The first one is not as much optimizing. It's more things that you should take into consideration when you're doing implementation using Dynamicweb or any other system for that matter. And we're going to have a look at some of the Dynamicweb specific things related to creating a website that can impact performance and give you some numbers on how it scales and give you some tools how to figure out how things perform. The second part, the scalable thing, is two things. How much content can we add to Dynamicweb before we end in problems, and what are the things that will happen server side, because we cannot, of course, not add endless amount of content into the solution, but we will take a look at how much content we can add and how much memory we're going to consume. And the second part, which is what we're going to spend more time on, is how we handle a lot of visitors to our website. We see a lot of cases in our help desk from time to time from websites that when they go live run into issues with performance because of lots of visitors, which has not been tested before going live. Having a solution with just one visitor can perform very well, but when you put it online, it can give you some issues. So we're going to take a look at that. And in the end, there will be room for questions, and you can just use the question bar anytime during the session, and I will answer them as we go along. So let's first take a look at optimizing performance on these Dynamicweb implementation. First, of course, a general note on website performance. Of course, you should all know all of these things. Basically, I'm splitting this into three different things. The server execution time, which is how much time do you spend on the server generating the actual web pages. That would be a page view, because we have some code that is executing, and that's the one that we can control inside Dynamicweb and the code we're doing. Then we have the download time, and that would be the same for all web pages in the world. How much HTML, how many kilobytes of HTML and images, JavaScript resources, images, and etc., should be downloaded for this website. That's also part of the performance, and we're going to take a look at why this is also important in the last part of this session. Of course, these are things that you take into consideration no matter what platform you're using. And the last thing is the rendering time in the browser. Of course, that depends on how bad or good HTML, CSS, and JavaScript we write, and that's not something that we're going to spend time on here. So let's have a look at our own website, Dynamicweb. I'm using the built-in tools, the developer toolbar that's available in Internet Explorer 9 and 10. So you have similar tools in Chrome and Firefox. I'm using this one. And one of the things I'm going to spend a little time on this performance thing, is if we take a look at this page, the performance is a lot of things. First of all, we see the first line calling Dynamicweb. We have a generation time of about 296 milliseconds. And apart from that, if we take a look at this red status bar, we are collecting 73 items of a total of 1.2 megabytes of data from this website. That's not very good, and that's also part of the performance of this website. So we have basically these three things. How much time do we spend on the server? That's what we see here. We have all the download of all these items, and we have the rendering on the page itself. And that's what we can see using a tool, a network profiler tool like this one. And of course, all of these things are very important. We're not going to spend time looking at how you minimize these things, because you probably know a lot about those. The thing that's interesting here is that yellow bar. How much time do we spend on the server generating the Dynamicweb page, because that's where Dynamicweb, the software, has an impact on the performance, and that's also where some of the things you do when you implement a website can have an impact on how much time we spend executing on the server, and that's before we get a response. Let's have a closer look at this request, the Dynamicweb DK request, the first one. It looks like this if we go into the detailed view of that view using this network monitor. And as we can see, this is the entire request. First we have a wait and some starting time. Then we have the actual request. As you can see the description down here, time to first pipe, meaning that the browser asks the server for this page, and it takes 250 milliseconds to generate the page on the server, and then we start receiving the things from the web server, and we have to download it using whatever internet connection we have. And then we can see the gap, which is how much time does it take for this page to actually get done, and that's 1.87 seconds. This is out of the hand of Dynamicweb for the server itself. That has something to do with all those files, as you can see down here, that are downloaded. You can see the red line or the black line out here is generating the page, loading the document in the browser, and getting all the resources that is needed for that document. That would be all those images, CSS, and JavaScript, and so on, and getting them into position and says this is the body unload event. As you can see, most of the time spent on generating this page is actually happening in the browser, and this is not looking that good, and that's probably because it's not the best implementation ever, and this is our own website, so I could dare to say so. But again, this yellow part, which is the execution part on the web server, is the one we're going to spend our time on in this session. But use this tool because it's a very good tool, and you hopefully use it already. These are extremely important if we are implementing a website that needs to be optimized for heavy load, or if we just want a fast and speedy website. Because if we have 100 visitors a day, these things are not a problem. If we have 15,000 visitors a day, and or even more, this kind of things that we're looking at right here is going to be an issue, because the server runs into problems, and a lot of weird stuff is going to happen on server side, and that's things that we don't want to run into. So that's we're going to take a look at that later on also. So that yellow part, the execution time on the server, we're going to take a look at some of the components that Dynamicweb, or some of the things that Dynamicweb does on the server. That is this yellow box. First of all, we have the layout engine in Dynamicweb, and I'm going to put a few words on how it works. The layout is the actual layout template that we're using to make the design in Dynamicweb. And as you all know, we have a completely normal HTML document with some classes and some IDs and settings. And this document is loaded on every page load in Dynamicweb. It's loaded from memory, not from disk, so we don't have a disk issue. But it's loaded from memory and into the layout engine itself that actually takes this HTML document and passes the document object model and reads the settings that you have put into it, which is content placeholders, where's the navigation, and where's the search boxes, and so on and so on. Of course, there is a minor performance overhead of this layout engine if we take a look at different sizes of layout files, the template files. If we have a 10 kilobyte layout file, we can't measure anything. All of these measurements has been done on my laptop. If we add a 100 kilobyte of layout file, we get a 3 millisecond usage of loading this document object into the memory. So basically, we don't have a performance hit on this if we are using relatively small layout templates. And you can see if we go up to a 0.5 megabyte layout template, which is quite a lot, but I'm not kidding, we see this from time to time on solutions, and we're going to get into why we see these big layout templates files in just a second. But as you can see, if we go up this size, we start to see a 0.2 second load time of the actual HTML into this document object model. And that is, of course, starting to be a problem, because 0.2 seconds is quite a lot of time. If we saw before, the Dynamicweb front page generation was 0.25 seconds in total. This is 0.2 seconds just loading the layout template into memory, and we haven't generated any content yet. The reason why some of these layout templates can get big is because the use of conditionals and a lot of includes and all that kind of stuff that is put into some of these layout templates. And this is the reason why we're going to this is because this is a very important issue on some implementation. If you're going to create a high-performing website or a website with a lot of users, you have to take into consideration when implementing that this can be an issue. We'll take a look at the conditionals in the templates. The reason why we see some very big layout templates is because they use conditionals inside them and say, if I have website ID 1, I'll do this bit of HTML. If I have area ID 2, I'll do another bit of HTML, so there will be a lot of HTML into the same layout template. That can be very clever sometimes for maintainability and so on, but it can also be very dangerous because if I have a high-performing website or a website with many visitors, I can run into problems because of that. So here we have some measurements on also some very large layout templates and the amount of conditionals that we put into it. Conditionals are, for the time being, relatively expensive to get executed in these templates. As you can see, a few conditionals doesn't make a big impact. 10 conditionals is 70 milliseconds, it's 0.07 seconds, so we can't see any of that. But if we start adding 100 conditionals into a 100 kilobyte of layout template, and go back, you can see 100 kilobytes is relatively fast loaded, but it makes impact on the performance if we have a lot of conditionals inside our layout template or in any other templates. So this is important to take into consideration, and also this conditional, the amount of conditionals is dependent on the size of the layout template, of course. So if we double the size of the layout template from 100 to 200 kilobytes of layout template, we can see one conditional now takes 15 milliseconds, and 10 takes 120 milliseconds, and so forth. So it can be an issue to combine a lot of conditionals with large layout templates. It would be better to put them into separate layout templates and use less conditionals, and then use some other rulings in the system to handle what kind of information is needed to render and so on. And I think we have some questions. Jürgen, the document 500 kilobytes is 0.2, of course, seconds, and not milliseconds, of course. So that's a wrong one. And all the others right here are also seconds. It's 0.03 seconds and 0.0 seconds, and this one is also seconds. So this is an error, of course. And Bruno asks if conditionals are if statements and if defines, or simply if statements. It's both, because it's running through the same engine basically. So it would be the same thing. You could say if you only have one type, only use if defines, or only use if conditionals, you would have a small performance improvement of that. So that was some of the questions I've got so far. Let's take a look at the next thing. Rendering navigations is also costing a little time on the server side. Also, we're going to take a look at that later on. Usually, a layout template consists of at least one navigation and up to 3, 4, 5 navigations. And the execution time of inserting a navigation into a layout template depends on how many items are in the XML that we generate. It's not depending on how many pages is on the actual website, but on the settings that we do on the navigation mode in the HTML template. If we say expand mode all and end level 99, and we have 10,000 pages, the XML will include 10,000 page items in the XML, and that would take a long time to render using the XSLT probably. So keeping navigation, the XML that is passed into the XSLT to a minimum can have an impact on performance. As we can see here, the execution time just one second, we have sound issues. The execution time is relatively flat rate from 50 to 150 items, and that's because most of the execution time is related to passing the XSLT on top of the XML and not generating the actual XML itself. But going above 150 page items in the XML will start increasing the time to generate the actual navigation itself. 50 milliseconds is very little still, so it's not going to be an issue, but it could be an issue when generating some of the pages, and then we see from time to time some navigation settings that retrieves a lot of XML or a lot of page nodes into the XML and only renders maybe 1/10 of it. So it might be an idea to optimize the settings on the actual XML itself. We're going to take a look at later on how you can see how much time your navigations is taking to render on the page. Next thing is custom modules and debugging of some of these things. We get a lot of cases into our support about performance issues on websites, and some of these things are related to custom modules and also related to some of the stuff we saw above. So I'm going to put a few words on this. First of all, a lot of the customizations that are done using notification subscribers and template extenders. And what we usually see and often see, especially on or websites with a lot of visitors, is they have some notification subscribers, for example on page load, that is needed to run in a specific context. For example, if we are rendering the products list page, for example, and we want to add some additional template tags into that. But the notification subscriber might be raised, or it will be raised on all page loads if you're using the page loaded notification subscriber, for example. So when creating notification subscriber, consider the context. Are you in a context right now? Check that in your code where we need this data. You can do it by using template tag exist, or you can check for parameters in the pure string or stuff like that, and only execute the code inside the notification subscriber when you need the data that's or the functionality that's in it. Because some of these notification subscribers are raised all the time, and maybe a lot of times. For example, if you have a notification subscriber on a list, for example, a product list or stuff like that, it will be raised once for each product in the list. It's not sure that you need the functionality inside it all the time. The same goes for template extenders. For example, we have the product template extender. It runs a lot of times, especially if you have a page of 50 products, and each of these products have related products. That product template extender is raised every time on that list, but also in detail view. And a lot of the times we see implementation of product templates that only needs to render stuff on the actual product detail. But this template extender is also used or called when you're creating a list of products in search results and stuff like that. And it is a good idea to check in your code, are we in the context of the product list or in the context of the product detail, and do we need the data at all? Do we need to execute any code? Because some of these extenders and notification subscribers, they run in memory. Oh no, of course they run in memory, but they run on database and pure database data, and talking to the database is expensive. So we don't want to talk to the database too much if it can be avoided. And this is especially important if we have websites with a lot of visitors. We're going to take a look at that later on. And we have some built-in tools in Dynamicweb to see this. The first one is debug equals true, which is a parameter you can add to the pure string of any given page, and we get some debugging information. I'm going to show it in just a second. And the second tool we have is something called Dbstat equals true. The first one, the debug tool, will show us which part of the page is taking how long to execute. And the Dbstat equals true will tell us how many database connections we have and how much time they take to execute against the database. And these information can help us optimize the implementation of the given page. It can also help us find out which of our notification subscribers and which of our template extenders is called and how much time do they take to render and stuff like that. And the last part we have is we have a built-in web page analysis tool, which I'm going to show you in the end of this. So this is my own local solution. I've added, debug equals true to the query string in the URL. You can't see that right now. What happens is that in the end of the document you see something like this, which is the execution tree. We have what is happening right here, the time, minutes, seconds, and milliseconds, and we can see here how many milliseconds did we use since the last entry in this one. So this is the delta of the last record, and this is the total execution time down here. And with this one, we can see different stuff. For example, right here we have a notification subscriber executed. We have Dynamicweb e-commerce front-end econ page loaded notification subscriber, which is one of our own notification subscribers. But if you have added notification subscribers into your custom solution, they will show up on this list. And you can see right here it took 0 milliseconds to execute. If you've added something that talks to a database or whatever, you can see how many times it's getting called and how much time Dynamicweb spent calling your notification subscriber. The same things you can see on page template extenders and stuff like that. So it will show in the list most of the time that when they're executing. Also, we can see how much time it took to load the layout template into memory. Didn't take any performance over it. Also, we have one call to a database right here. This is collecting all the paragraphs of this specific page being rendered. And we can see it took 78 milliseconds to retrieve this data from the database, which is definitely okay. So at this point, we can see we've spent 234 milliseconds to generate this page and what it has been spent on. And then we have an issue right here because we have a navigation. And it took 2,000 milliseconds. That's 2.2 seconds to actually render this DB navigation top now. And we can go into our layout navigation and have a look at what is going on in that specific navigation. We can see the other ones are pretty quick. This one failed badly. We'll go ahead and take a look at what is happening. In this situation, I think it renders 10,000 XML pages in the XML, and that's of course giving this performance overhead of 2.2 seconds. So this is just to illustrate that we can use this debug true to find out what part of my page is taking a long time to execute. Right here we have before content and we have after content. That would be all the paragraphs and all the modules on the page. This is a page with just one paragraph or a few paragraphs and no modules. If we had e-commerce installed on this page, you would see a lot of records between this one and the after content notification, where we can see the e-commerce being rendered and all the notifications being executed and all the template extenders being executed and so on, and we can see how much time it takes and find potential performance issues using this one. Also, we can see how much time is spent on executing the actual template parsing. We can see the template, it doesn't take any time to execute this one. Very useful tool to take a look at. Do I have any performance problems on this particular page, and in which part of the page or the functionality or the implementation should I look for this issue? The second one is called Dbstat equals true, and this is the same page, and we only have one connection, and that's the one getting all the paragraphs from Dynamicweb, and we can see we get a lot of weird code here. That's the stack trace of where this was called. On custom solution, you can also do this, and you would see your custom code if it calls databases. And you get connection number 1, and you will get a list of all the connections you have on a given page. And if you go above 10, 20, depending on how much load you have, and if you're running Access to SQL Server, you might want to consider taking a look at the implementation or your custom module. Do we run into problem? Some kind of problems. A normal page in Dynamicweb would create 1 to 3 database connections or talk to the database, but if we add e-commerce, of course that number will increase, and depending on the various modules, we would see various numbers of connections. This can be handy if you have a notification subscriber, for example, or template extender, the product template extender that we talked about just before. Do we talk to the database inside that one, and is it being called excessively in our rendering of a specific page? We can use the Dbstat equals true to find out if that's the case. And also we can see how long it takes to execute a given a SQL against the database. Of course, we can also use some external tools. This is the Ecotech profiler. It's a free tool. You can download it and you can attach to your local installation of your custom solution, and you can start profiling your code or our code, and you can see if you have performance problems or any kind of issues with a given page. Run this tool and you get a report like this, and as you can see down here, we can see page we got output took 44 milliseconds, and 43 of those milliseconds was used for passing the conditionals in the templates. We can find a lot of useful information inside this one. You can also, if you profile your custom code, you can see which part of your custom code is causing the problems, and if you call into our API, you can see which parts of our API is causing the things. Okay, I have a question from Peter Mokal. If we're considering using stored procedures instead of direct SQL queries, yeah, we do that all the time. I think we use it some places in e-commerce because that is using only SQL Server, but most of our solution also supports other databases, and stored procedures is not a good idea in that context. There's no problems using stored procedures in custom modules, for example. You can do that. No, we don't have any single stored procedure in our solution. Okay. I thought we had some in e-commerce. Okay. This last tool I'm going to show you is a relatively new tool that you can find in the paragraph list on all the pages inside Dynamicweb. We have, if you go to the Tools tab, and you have in the reporting section, you have something called webpage analysis, which will give you one of these tools, as you would probably know them from the internet. It will tell you something, how many modules do you have on this page, how many database connections, paragraphs, and images, and so on, and how much they fill. And we have some recommendations. Are we good, or do we have some warnings? Because the JavaScript files are quite big. You might want to take a look at if it's a problem, and the same with images and CSS files and so on. You can use this tool to quickly get an overlook of, do we have a problem on a given page that we need to take into consideration. We also have the rendering time shown down here. And then there's Dynamicweb itself. All of this is implementation and custom modules related to things that I've talked about so far. But Dynamicweb, of course, is not in all situations performing like a rocket. So, and I have a bunch of examples of things that I've done wrong in the past couple of months on cases I've seen. This is just to have you consider, are we using the system in a way that could give us some kind of performance problem, and then maybe take a talk to us before we go live so we can help on some of these things. So some of the problems I've run into or seen cases with this. And a gallery with 150 images of a total of 16 gigabytes, that's some very large images that gave us some kind of some serious performance issues when we went into production. And we've seen 100 custom fields on a product. It also gives some implications on when we went live. It's not a problem running just one user on a test environment, but if you get concurrent users on solutions, it can get into problems because we run out of memory or CPU or whatever is going to happen on the server. Other examples, 350,000 users in one group, 21 images in one folder, 20 e-commerce modules on the same page, 650,000 products in one group, and 4,500 products rendered on one page. All of these are some implementations that have taken Dynamicweb over the limit, and this is causing performance issues on these installations. So take it into consideration. Am I doing something that Dynamicweb might not have thought of that they would do? And take a measurement, and if you run into a performance problem, give us a hint and we might be able to fix it. A lot of these things can be fixed in our code, and we are willing to do that, so please let us know, but take it into consideration, and best before you go live, so we don't have urgency when it happens. So next up is the scalable Dynamicweb solutions. How do we scale solutions to a lot of content, or how do we scale it to a lot of visitors? So we're going to spend a little time on that. First of all, we're going to take a look at what happens if you add a lot of pages in Dynamicweb. So I made this test on my laptop, and I only had one website. I didn't have several websites in the websites module in Dynamicweb. So I added all these pages to just one website instance, and this is what happens. And with 100 pages, it takes 0.25 seconds to render this specific page with the implementation. This is just a normal page with paragraphs and nothing else. And you can see we have pretty much flat rate on the front-end execution up until 22,000 pages, and then things are starting to happen. First of all, we have this 9 seconds warm-up. That means when you add new pages into Dynamicweb or the web server restarts, the page, all the pages which are cached in memory, it needs to be recached or re-initialized, and it takes 9 seconds with 11,000 pages. It takes 19 seconds with 22 pages. And we're starting to see some relatively heavy memory consumption on the server side. 45,000 pages is taking up 1.2 megabytes of memory on the server, so this could give us problems if we're running to 32-bit IRS. We're going to take a look at that later on. And we start to see some slightly slower execution times on the website. But basically, having a lot of pages in Dynamicweb does not influence the execution time or the performance of the front end, but we see some issues, especially on application startup in Dynamicweb. The same goes for stuff like products or product and group relations. We don't have any issues there at all. But first of all, we don't take all the products or groups into the cache, so we don't see the warm-up times, and execution times are more or less as flat rate as these are, because they're more dependent on the indexes on the database than on the actually indexes in memory as the pages are. So now we have a slide with a lot of numbers. So scaling Dynamicweb for many visitors. This is where things usually can go wrong. First of all, an optimized implementation is needed. So all the things we took a look at in the first section or part of this session, of course we need to take that into consideration, because if we don't do that, we're not going to scale anywhere to lots of visitors. So I have an example of 15,000 daily visitors or sessions on a website. That's quite a bit. And we take some assumptions that these 15,000 daily visitors, they make 10 page views. that would be 150,000 page views a day on this solution. And each page view uses up to 50 resources in average. We saw that on the front page of our Dynamicweb website, we had 70 of those. So I've set it to 50. It might be a little high because some of it is also cached on the browser. But if we take these 150 page requests and times 50, we're going to get 7.5 million HTTP requests against the web server. So it has to serve all these requests. Even though they're cached by the browser, it still has to serve the request. It doesn't have to send the data, but it has to serve the request. So the next thing we're going to take a look at that is the visitor pattern. When during the day are these visitors going to be on the website? 80% of these usually visits a website between 8 to 24, probably more. And peak hour is usually between 1 and 2 in the afternoon. And that gives, in our peak hour, given that we have 20% of our visits in the peak hour, which is relatively normal, that would give us, in that hour, 3,000 visits. So that's going to be our peak hour where we have to take the best performance into consideration. Every visit has a duration of 5 minutes, and that gives us, because we have 3,000 visits of 10 page views, 30,000 page views in this hour, and we divide it by 12 because we have a duration of 5 minutes, and divide it by 60 to see that we have 41 page views every second during this hour between 1 to 2. And because we have 50 resources on every page view, we will have approximately 2,000 HTTP requests every second into the iOS, asking for images and pages and JavaScript files and so on. And this is just one of these calculations that is needed to have done before you go live. So you have to take into consideration, do I need a web hotel on a shared hosting environment with hundreds of others, or should I maybe have a dedicated server, and how big should that dedicated server? And I have a question. Yeah, it's a very technical one about if we're using if we're considering using cookie mode for sessions instead of using use the database mode instead of cookie mode. Basically, Dynamicweb doesn't care. You can use you can change it in web config on a specific solution and use either of the other models for session modes in Dynamicweb. I don't think Dynamicweb is going to be not working if you change to one of the other modes. But as a default, we're not going to change from the cookie mode as we're using today, the cookie memory mode. So these numbers, it's important to do a calculation like this, especially if you have a customer or an implementation that you know needs to take a lot of requests, because these numbers say 2,000 HTTP requests every second, which is actually the default maximum on some iOS installations. I think some of the newer servers have a little higher, but at this point we're going to run into problems on iOS if we don't do anything. And of course these requests is also dependent on how much time we spend delivering these 30,000 pages. Of course, if we take 1 second on each page, we're going to take up these HTTP requests for a longer time than if we only take up 1/4 of a second. So the execution time of a given page is very much depending on how many HTTP requests that we can serve. And this is only visitor data. On top of that, we get all the data from, or all the requests from the search engines that are visiting the website also. So that we have to take into consideration. And I have a question from Kevin Steffer about server sizes. I think we're going to take that in the end of the session. So some of the consideration that we need to take, one is the average page execution time, because that's the yellow box we see here, because that's going to take up the HTTP request is going to take up the CPU on the server side. So this is, of course, some very important numbers to know before you go online, because that's basically going to be the limit if you times your number of visits with your average concurrence, the average page execution time, and the number of HTTP requests. It also has an impact on how much memory is needed, and what is going to happen if we have more users and more sessions and more threads into this, because it's going to take up more memory than in our test environment. And we have a question about load balancing scenarios coming up in a second. What are some of the things that we can do to improve performances? First of all, this use full page caching in Dynamicweb. It boosts performance quite a lot, and it takes execution time from these 0.25 seconds or 2 seconds on heavy pages into as long time it takes to load an HTML document from the disk and send it out, usually about 0.05 seconds. That's more or less nothing. So this is a thing that you can do that can really boost performance of an installation that you have on your server, because instead of taking up all that amount of CPU cycles and reserving all those HTTP requests, if we have this time spent, we can take it down to this one, which is actually going to give the server a lot of more, especially CPU and memory, but also the amount of users that we can execute at the same time. On a page, on the properties, you can go into the Advanced tab, and we have the caching button right here, and we have 3 types of caching. Usually all the pages on default mode, meaning that Dynamicweb will figure out what to cache and how long. But you can go into the one called entire page and cache it, for example, for 15 minutes. Then the content on this page is only going to be generated and executed and passed and all that from the database every 15 minutes. So you can serve the same generation of data into thousands of users. Of course, if you change any content on the given page, the cache will expire by itself. So there will be no latency on updates using this caching mode. This is a very good thing to use, especially on the front page, because it usually takes 50 to 60% of all the page views on a given website. And you can also do it on section front pages. For example, on our website, we have the first front page. We also have a products page, and customers page, and so on. And also set it on those pages, because they're usually taking by far most of the traffic on a website. So enable it to really boost performance and the scalability of the website. Of course, you cannot use it all the time if you have dynamic content depending on the user that you have. For example, if you're running online marketing center, the profiling things or stuff like that, you cannot use full page caching while you're doing that, because every user will have different content, so there's nothing to cache. Then there is, of course, the platform and configuration. First of all, a 32-bit iOS has a maximum of 1.2 or maybe up to 1.8 gigabytes of RAM. So it's not very suitable for websites with a lot of users or a lot of content, because we're going to run into memory issues pretty fast, especially if we're in a shared environment. If we change to 64-bit iOS, we can take 70% of memory that we have available on the machine in total. So we can get some pretty big application pools up and running, and that can be very important if we have a high performing website with a lot of visitors. And also one thing that's, if we have a 64-bit iOS with enough memory and CPU, we should change the maximum of HTTP requests, because it's for some reason really low on default installations, and we can easily put it up and get a lot more juice out of our server. So what else to do? Of course, we can separate the SQL server and the web server into 2 different servers instead of using the same one. So the SQL server will have its own memory, the web server will have its own memory and CPU. Doing that, we can take probably twice as many visits of course, as at least twice as many users if we have the same things on the same server. You can also use more than one web server. Dynamicweb supports clustering, so you can enable having 2 web front ends and maybe a SQL cluster that would be 4 servers in total. And you can configure this inside Management Center, or our service desk will do this along with Post Nordic or the hosting partner. And what we see here is the configuration of it, and what actually happens is that these web servers will start communicating to each other about especially the caching on the 2 different web servers. And we can use that, of course, to put 2 web servers in front of this, and in that way double the amount of visitors we can take into the solution. Also, we have an option to use a CDN. It's a very hidden feature in Dynamicweb. If you go into global settings and add a CDN host, all image resources would be changed to this. HTTP, we're lacking some slashes right here. And it will point all the image requests to the CDN. Of course, you would have to have all your images both on your web server and on your CDN. But in this way, we can take away by far most of the HTTP requests to the server, so they only have to execute the dynamic pages and not the static resources. So you can, in that way, put this 5th server into this configuration, so we actually have 5 servers serving up the web server, and that can give quite some performance also. But one last thing is, before you go live, you might want to know what's going to happen when I go live. What happens if I add 500 users to my website at the same time? When will the server give up, and when will the solution give up? And we can do a stress and load test. These are some examples from some stress and load tests that we can conduct for you before you go live. We use Visual Studio for doing these stress and load tests. But basically, what we have here is the blue line is execution time in, as you can see here, and we have to divide this 1 by 10. So it's around 0.2 seconds to execute a page, as we can see down here. And this is the amount of users. We have to time this by 10. So 200 concurrent users will give this execution time. 400 concurrent users will give this execution time, and then we start to see some performance problems in the page execution times. And so the limit for this configuration, this server, and these pages we're visiting is just around here, maybe a little before, and this can be very nice to know before you go live, especially with high-performing websites. And we have some questions on how common storage should be configured for load balancing scenarios, and the CDN feature, does it include get image or only static images? The first one, if you're running a clustered setup like this one, you can do it in different ways. The way we do it in Host Nordic is that we have the same network storage attached to 2 or more web servers, so they basically share the same disk drive, and then you mount them as normal disk drives inside the server. And we're not using network path, ULC path to do this, because it's a directly attached storage to the servers down here. You will have to talk to some of the system administrators down there to get the precise explanation on how this is set up. And we have a question from Lars Sørensen about the CDN. If it supports the get image, and it doesn't. It only supports static images. So one last thing. This is the same stress and load test, but with a different configuration of a page. We can see pretty early in the process, already around just before 200 and 160 users or so, we are getting into a performance problem on this solution. It's basically the same server as this one, but it's another where it's a gallery module with a lot of images and very large images that is put in. So we can see here, depending on how you configure or implement your website, I think the decisions you took when implementing can have a huge impact on how many concurrent users we can have before we are running into server performance issues. So that's all for now. And questions, we got a feature request from Lars Sørensen to move GetImage to be CDNable, and that's taken into consideration. And we have a question from Per Søgaard about what are the best performance settings on GetImage HPX. Is it a problem using it on all images, or are the scaled images cached? Yes, all the scaled images are cached. But GetImage.hpx will always be slower than going to the static image itself, because you have to go through the .NET engine, and there's an overhead of that by itself, and also things that's happening in GetImage. But the actual image is only generated the first time you're using it. It's also a possibility to use the thumbnail features in the file manager instead of using GetImage, and you can have a performance gain by doing that. And it would be best to use GetImage as little as possible if you want to maximize performance. And we have a question about, have you thought about replacing GetImage with another tool? And yes, we have, Søren, and it's on the agenda, because we know the issues with GetImage, and image resizing.net could be one of them. Yes, Kevin, we are aware that it's pretty slow compared to other image requests. And Nuno asks, do I have to go to page to set caching settings, or is there edit multiple pages features? There is no hidden edit multiple pages feature. The only shortcut is go to the SQL tool in Management Center and execute a SQL statement directly on that one. But that's also cheating. So you have to click through pages. Yeah, Firehost. Thank you, Nuno. Per Søgaard asks, is it best to avoid the compression setting on GetImage? I don't think so. Compression should be good in any scenario, so unless proven otherwise, it should be there. So, any other questions? Otherwise, we'll stop the session. Well, thank you all for attending. The next webinar is going to be next Thursday, and you can sign up on Engage, and you'll see also the subjects of the next session. See you in a month, where we'll have the next tech crunch. Subject is still unknown. If you have any good ideas, feel free to let me know. And in 14 days from now, we have a preview of IT based on Dynamicweb, which is also going to be very interesting. It's going to be held by Powell, so be sure to sign up for that one. Bye, everyone.